Deb Mishra is an associate professor in the School of Civil and Environmental Engineering at Oklahoma State University, where he teaches courses in the areas of geotechnical engineering, pavement engineering, and railroad engineering. His research interests are in the areas of advanced laboratory characterization of pavement materials, instrumentation, performance monitoring, and numerical modeling of civil engineering infrastructure, and application of machine learning and artificial intelligence for network-level pavement, railroad, condition assessment. Please help me welcome Dr. Mishra.
Good morning. So back when I was a grad student, getting ready for my first conference presentation, my advisor told me, whether you are a good presenter or not is indicated by if your audience is interested in you or not. However, if you are the last person standing before a room full of people and lunch, then God help you, all right? So here goes to my advisor. All right, let's get started. So my name is Deb Mishra. I'm a faculty at OSU, not Ohio State, Oklahoma State. Presentation today is on analysis of traffic speed deflection device data for pavement structural evaluation. So first of all, thanks to my graduate students, Kaustubh Chatterjee and Fazle Rabbi. They're sitting over there in the corner. They're the ones who do all the hard work. I just take all the credit by standing in front of people. All right, why is this not moving? Okay, perfect. So we've been talking about a lot of really nice technologies this morning and stuff like that. So now let's take a look at what are we actually driving on the transportation infrastructure, okay? Pavement maintenance is a huge portion of any DOT's budget, okay? And how the pavement maintenance decisions are taken is a very, very important factor. I mean, there is something called pavement management systems, pavement maintenance planning systems and stuff. We have all heard of all of that, okay? As time goes, the curve, the performance curve actually is not linear, it changes. And at what point you actually address it and at what point you fix the thing actually really determines whether you are doing something that's cost effective or not, all right? And when you do maintenance in time, you can actually save up to 10 times of the cost and stuff. This is all based on literature. So whenever we have our pavement network maintenance, all DOTs, they have these pavement survey vans. Either they own it or they contract it out to some kind of consulting company, and then they go around and take the survey of the pavement in terms of its cracking, in terms of its roughness, in terms of its rutting and everything. And for those of you who don't know, our OSU, Dr. Kelvin Wang and Dr. Josh Lee, they are basically world leaders in this area. They do a lot of really, really cool work. Both of them are here as well. But what traditionally has been missing in the maintenance decisions for DOTs is the structural condition of the pavement. So essentially, yes, it is cracked, the surface is cracking, but is that because there is a bad asphalt mix? Is that something wrong with the surface layer? Or is it actually something more deeper? Is the base layer defective? Is the subgrade defective? How can we find that out? How can we find the actual cause and try to address that in our maintenance and rehabilitation without just going one solution fits all kind of an approach, right? So for that, there are, when you go to project level decisions, there is something called falling weight deflectometer. I don't know if this laser, there's a laser pointer or not, maybe not. There is something called falling weight deflectometer. That's basically the picture on your top left. You have seen this probably. What it does is it basically drives on the road. You stop at a point, you drop a heavy weight, and you measure the deflection of the surface and say, okay, this is something called a deflection bowl. And depending on how the pavement structure is, you can actually analyze that data and make inferences about that. Okay, so that's a very standard practice for most DOTs. Even Oklahoma DOT used to have a very rigorous FWD program, but then later on they kind of stopped, reduced its usage because there are issues with it. You have to control traffic because that vehicle actually stops and tests at one point and then moves on. So you have to control traffic. So is that really something that we want? The requirement, like if you go to AASHTO requirement or stuff, then per every point, you actually space your testing about 500 feet apart or tenth of a mile apart. So is that good enough data? Like, do we need more frequent data? If we do more closely spaced points, then our testing time is going to increase, our traffic control demands are going to increase, and that's a big, big challenge. All the DOT folks will agree that when you're talking about a district level, then the budget does not really allow for rigorous traffic control all the time. So that's when the move went into continuous pavement structural evaluation, which is called the traffic speed deflection devices, or TSDDs, or sometimes called TSD, or traffic speed deflectometer. That's basically the figure on the top right. Okay, so that's where that's what this talk is about and what those devices can do. Okay, so if you go into theory, and we are not going to go into theory, the TSD that is operational in the US right now is actually something that's manufactured by Greenwood Engineering out of Denmark, and then ARRB actually runs that. It's called the TSD, or the iPave is the name, but essentially that is based on the concept of Doppler lasers, and these are lasers that actually shoot on the pavement, and as this vehicle is moving, they actually measure the velocity of the pavement surface that's moving, and then you can do all sorts of mathematics to it to get pavement deflection. Okay, we're not going to go into any of that detail right now. So when the TSD came, there was actually some talk about, is it actually a good enough indicator, right? Is this doing a good enough job as the FWD, or the falling weight deflectometer, which has been the gold standard for several years? And the joke around that is that when falling weight deflectometer started several decades back, the first thing that was tested is that doing a good job that an actual truck is doing, right? So back then we spent a lot of time actually checking if the FWD is doing what a real truck is doing, and now we have a real truck, and now we are trying to compare if that real truck is actually doing what an FWD is doing. So it's kind of, that's how practice is, that's how things go. That's okay. But anyway, there has been a lot of work that has been done to compare whether the deflections from the TSD is comparable or is actually good enough, and it gives good enough data as an FWD. So these are some plots from literature. This is some of our work. My work. So by the way, before I joined here, I used to be in Boise State in Idaho, and I was there for 5 years. And for Idaho Department or Transportation Department, we did some work on this field. So this is work from there. And if you can see the box plots for the FWD, the median value was about 13.47. For the TSD, it is about 13.02. So we can all agree that they're doing a good job they're comparable. Okay, and then there has been structural number. The pavement folks will identify what it is. Yes, it is AASHTO 1993. Yes, it is not something that the pavement ME or the modern method is using. But again, you can compare the back calculated or the remaining life structural number, etc., and they're also comparative. And then there is another one on modulus calculation as well. So essentially, all these slides and graphs were to establish that the TSD has been established to give data that is good enough and reliable enough for our usage. Okay, so now let's move on. What we need to do. So why should we consider structural condition during network level pavement monitoring? What's the need for it? Okay, I should not say all, because several DOTs are now moving into this direction, but previously everything was based on the functional condition, like cracking, rotting, IRI, roughness and stuff. And then you have all the prioritization program and stuff. But what about, wouldn't we be more educated or more informed if we actually checked what is the structural condition of the pavement? So here is a study. This is out of Dr. Ken Messer, who owns InfraSense. Most of several of you may know. He did some work for Idaho, and what he found is that he analyzed 735 miles of data, and what he found the benefit to be about $21,000 per mile over 50 years, and then the cost is about, or essentially per rating cycle, it's 2,100 miles per rating cycle, and the cost is about $300. So it's a cost to benefit ratio of 1/7, or benefit to cost ratio of 7. So you can, any DOT can pretty much say that, yes, this is very, very beneficial. So this is Idaho data, okay? This is not Oklahoma, this is not a nationwide, so I want to say that. And then there are, I don't expect to even go over this slide, but what I'm saying is there are DOTs who are coming and talking about their decision matrix and saying that, yes, we are going to incorporate the structural evaluation data into this, into our decision matrix, and then be more informed rather than just taking, like maybe we are actually doing a full depth repair or reclamation where it was actually the problem was only superficial. So imagine the amount of money we're going to save. In fact, one of the things, one of the DOT engineers, he keeps saying that, let's just say we collect data every year, but if we find one project where the decision would have been wrong compared to what we would do using this continuous deflection data, then we would have already many times recovered the cost of testing. So that's essentially the reason for doing this work. Okay, so there is a pooled fund study going on by the FHWA where I think per last count, I think 26 states are participating in that. And all the Virginia Tech or VTRC is actually the lead for that, and ARRB is the primary consultant collecting all the data, and Oklahoma DOT is actually a part of that study. So what happens is that every DOT puts in certain amount of money every year and then works with ARRB to collect data. Now, how they are implementing into their pavement, management system, their decision matrix, what are they using, that all changes from state to state. But again, if states are jumping into collecting this data, ODOT jumped into collecting this data. In 2019, there was data collected. In 2020, data was collected. And in 2021, also there was money, but I don't think it's going to be collected this year. It's going to be collected next year. So OSU, we got a task order with ODOT, thanks to Angel Gonzalez. I don't know if Angel is here or not. I don't see him. But he was the technical supervisor for this one. So we actually took OSU's data, and we actually worked towards developing a tool that we are going to hand over to ODOT, and then ODOT will be able to import any TSD data or continuous deflection data, and they can do all the analysis themselves, and then they can come up with decisions and stuff. So we are doing this on the platform of R, which is an open source thing, so that we can just give it, and any engineer at a district level also can actually do this. Okay, so we've been working on this. We got different matrices to decide on which one is good, or which road is good, which road is bad. I'm not going to go into any of the details, but essentially you can calculate, or you can find out where are the soft spots in that roadway, if there is a problem in the surface layer, in the intermediate layer, in the subgrade layer, overall structure. If you incorporate GPR into it, or ground penetrating radar, which this data does not, now we have the layer thicknesses as well. So you can do all sorts of things. You can back calculate moduluses, you can design rehabilitation methods and stuff like that. So, and you can do a lot of visualization on, different structural indices. I'm not going to go into this because of this is more of an overview presentation, but you can see whether the subgrade and the surface are correlating very well. They're in the similar structural condition, or a surface is good condition, subgrade is bad condition, and all sorts of combinations. By the way, just one plugin is that if you go over to the demo, in one of the stations, my student Kaustav has a system set up to show this Hawkeye website where all the TSD data is there. So you can stop by there and we can do all the detailed discussions. And basically the whole idea is at a network level for different roadways, you can plot different matrices, and you can say, okay, here is where my outliers are lying, so let's go there and do some detailed investigation there, and then we find out what is problematic and stuff. Okay, let me, so this is a couple of stuff from Idaho that we did. We actually did a lot of network level work there, compared the FWD to TSD, and found really good match. There is some work involved. The data needs to be aligned properly. It needs to be understood properly. You need to have some idea about the layer thicknesses if you are doing back calculation, but it is doable. What ultimately we also did, so FHWA actually developed a spreadsheet program for back calculating individual layer moduluses, and we were able to get that. We modified that a little bit. So now we have the ability, so for any ODOT roadway or any district, if we have the layer thicknesses and just the TSD drives over it, we can actually back calculate and propose like design, overlay design and everything. So all of that is currently available. Okay, and just I'm going to show a couple of snapshots, and then that's the end of my presentation. Here is a tool we developed. So there are two screens you'll see. This is a MATLAB-based program, and the next one, this is an Excel-based tool we developed, my research team developed for Idaho, and we handed them over, and we said that if you just give us the layer thicknesses, the FWD data, because that work was an FWD, and then whatever miles you have and everything, we will actually give you a frequency distribution of what portion of your road is in good condition, what portion may need maintenance in the next few years, or what portion needs immediate, and the portions that need immediate, what is the problematic layer? Is it the surface, is it the base, is it the subgrade, and what is actually the likely rehabilitation method and stuff like that. So the whole idea, we had a meeting with ODOT last week or a couple of weeks back, and the whole idea is if ODOT continues to collect this data, and if we are able to work with ODOT on this, we will be able to do this now at a level of continuous deflection or traffic speed deflection. So no traffic control needed, and we have continuous data. So not only network level decisions can be better, but even this data can be used for project level decision making and overlay designs and everything. So there is a lot of potential in this data. This is a great pooled fund study that ODOT is a part of. In summary, basically, that's essentially what we're going. This is my research group at OSU. Before I end, few people I want to thank: Angel Gonzalez, Matt Swift, Jerry Deladen, and Nathan Kabiri of ARRB. They're the ones who collect all the data. I bug Jerry very often on questions from this and everything. And of course, the organizers of this, OTRD, Dr. Zaman and Brian Cooper and everybody for giving me the opportunity. So yeah, that's it for me. And if you guys have any questions, I'll be happy to take. Thank you.
Questions for Dr. Mishra?
Hello, Dr. Mishra. Thank you for your nice presentation. And I learned a lot about the TSD and structure monitoring. Well, my question is that if we compare a network, a transportation system to our body, the structure problem sounds like some problem inside our body, and the surface condition is the appearance of that. And my question is that if I didn't notice any surface appearance from outside of my body, I can eat, sleep, have fun, attend the meetings, study, and doing everything good. But would I spend money to detect if there is inner problem inside my body, and if I am not rich?
Okay, perfect. I think that's a great question. And if I understand correctly, what he's saying is that if I don't have any surface outside symptoms, will I go and get an endoscopy done or something just to figure out if there is something wrong, right? The answer is absolutely not. So
yeah.
And great question. TSD, the structural evaluation, is not, I say, it's not a replacement for the network level per pavement survey or anything. In fact, the iPave vehicle or the TSD vehicle that's being used, it is actually equipped with all the lasers and cameras and everything to give you the rutting, the cracking, the roughness, the profiler to give the roughness as well. So it is actually, yes, it is, you have to be able to drive well on the surface, or on the roadway, with, and if you're able to still do, there may not be an immediate need to repair anything, but wouldn't it be really good if you know that when you're collecting the roadway as well, like for example, every DOT has a 5-year plan, right? Every DOT has a 5-year, these are the projects and stuff. So it's not a recommendation to just completely replace your network level pavement survey just by this TSD, because it's probably going to be extremely expensive as well. And you are not going to fix everything next year or something. But if there is a 5-year plan or something, and there are projects that are likely to happen, it wouldn't be really good to find out what is actually the structural health of those things, along with, of course, you are getting all the surface level and roughness, riding qualities and everything, so that you are actually equipped to give, or you are informed to give a very good solution or rehabilitation strategy, rather than just doing something without knowing what's wrong inside. I hope that answered your question.
In addition to that, would you do any material testing, structural testing to confirm what you're getting from the TSD and W? That's good.
So the question is, would you do, in addition to the TSD, would you do any material testing? So the answer is, what are you using the TSD data for, right? If it is a project level decision, right? If we are actually doing, because there are state DOTs that are moving into project level decisions here. It's not just a network level pavement management like decision making tool. So if you're now at a project level, then absolutely yes, because remember, when you actually, traditionally what do? You do FWD, you probably take some course to find out what the thicknesses are. Now, if you have a GPR system that is very reliable, you may not need course. But if you are actually doing an overlay thickness design or something, it would probably help to have an idea about how strong your base is, how strong your subgrade is and everything. But it probably is that. Unfortunately, it's an answer that varies from project to project. So in some cases, yes, absolutely. Some cases, maybe not. Maybe the back calculate or the deflections will actually, in fact, in Denmark, there was actually some work to predict directly mechanistic values like asphalt, bottom of asphalt, tensile strain, just from the TSD deflections. There is actually work going. So if you can go into that, then maybe you can just input that into a pavement design software and then just directly do without needing a detailed material testing. But that changes from project to project.
All right. Thank you, Dr. Mishra.
Thank you.